Okay, let's restart. Finally working. All right, welcome everyone. My name is Matheus Amazonas Cabral de Dradi. I'm here to defend my thesis. My thesis entitled Developing Real-Time or Real-Life Task-Oriented Applications for the Internet of Things. My thesis is part of my master's in computing science with software science specialization. The research was performed at the Institute for Computing Information Science here at Radboud, specifically at the software science department, the supervision of Rinus and Mart, and the second reader was Peter. Where's Peter there? Yeah. Okay, let's start. I'm going to assume that most people here know what a task-oriented programming is and what iTasks is, but for those who don't, I'm not sure if there's anyone. It's a new programming paradigm that offers really high-level abstraction on where its central concept is a task that has an observable value, and users perform tasks together over the internet and to achieve a common goal. It's clean. There's an implementation of task-oriented programming in Clean. It's called iTasks, and it supports many platforms. And the Internet of Things is this great phenomena where devices communicate over the internet, and they process data and they exchange data. And these devices are not only computers and laptops anymore. They're putting microcontrollers on many things of our daily lives. Like there are microwaves that are connected to the internet nowadays. There are fridges, shoes, and many other things. And there are automation of greenhouses that are made with microcontrollers. So is this phenomenon that is growing quickly, but until some time ago, there was no TOP way or task-oriented way to program these devices. And then the mTask was created. It's an embedded domain-specific language embedded into Clean, and its motivation was to enable the controlling of microcontrollers using a task-oriented way or in a task-oriented way. And it has two views. The first view to be created is a code view, where it's an embedded domain-specific language, so a view is interpretation of the language. The first view generated C++ code that would do exactly what that task that you created on the task would do, but it had a problem that was static. Once you compile it and upload it to the microcontroller, you cannot change it, and you need to reprogram the microcontroller in order to send a new task to it. And then, that has two problems. First, microcontrollers, they have a limited number of cycles that you can write to their flash memory, which is where the program is. So if you're in a really highly dynamic environment, you don't want those cycles to end, and your microcontroller just stops working. And the second one, there's some devices that are hard to reach. They're on the field, and you need to plug them into a computer to upload a new program. There is something called over-the-air programming, where you can reprogram the devices using Wi-Fi, for example. But the problem with that is that you need to erase the microcontroller's memory, and then you lose the tasks that are running there currently. So it stops working for a bit, and then you reboot it with the new task. It would be ideal if you could just really send tasks dynamically. And the interpreter view was created for that. The interpreter view gets the language construct and compiles bytecode to it. And this bytecode will be interpreted by a client running on the microcontrollers. So each client will have each device will have a microcontroller there. You have a client there with an interpreter that will interpret that bytecode. And since the microcontroller has a connection with the server can send new bytecode dynamically. So you can send tasks dynamically to the device. And during my internship, I built a simulator, which gives you a really good ability to debug and test tasks running on these devices, because you can peek into the state of them. Like you can check how the memory is, the memory layout, where the program counter is. And it was really good for developing applications. But then, here is an example of an mTask application. Is Factorial, which is becoming recurrent in my presentations, which calculates a factorial of a number using mTask. This is an mTask. You have a shared int, which is how you're going to send back the result to the server. You're going to publish a new value there. you have an int, which is a number of that you want to calculate, the factorial, and then you have an mTask with an interpreted type of bytecode. And the factorial just looks like, as you can see, this version of mTask is an imperative language. And this is just a standard algorithm to calculate the factorial. As you can see, there's no for loop here. We do repetitions of code, just sending a task with saying repeat this task every 1 second or 10 milliseconds, how much you want. And then you just basically, it's a while true loop. And if you want to stop the task executing, you can just use return. So here, just a standard factorial. Once you reach 1, you publish that value. So it's going to update the SDS and the server will get that. You're going to turn an LED 1 on, and you're going to return. Return is just saying stop running this task. But as you can see, there was a type of application that was developed with mTask, and there's a gap between this kind of application and the real-life applications that we see. And factorial was actually one of the more elaborate that was developed before. There were a few that were simpler than that. So we were wondering if we could use mTask to build bigger applications. And that is actually the research question. Is it possible to develop real-life IoT applications using mTask? If so, how can the development process be improved? If not, what are the challenges to make it possible? And then I chose to answer this question, research question by example. Namely, I tried to develop an application, a real-time application using mTask, an IoT application, and see what would come out of it, if there are challenges, if I could solve those challenges. If not, is there a way that we can go to solve those problems? And I have the first step to do that was actually pick an application domain. And we have some ideas of what we wanted for some applications. And not going to list the entire criteria. Some were more explicit, some were more kind of implicit, but we want an application that was IoT for sure, that was simple or that was not trivial, that just making a LED blink and that's it, but not too complicated that I cannot develop during the research. It also had to be an interesting problem, not only interesting technically, but an interesting problem as if the interesting application is solving an interesting problem. And which means there are people out there trying to solve the problem, or there may be companies that are selling solutions for that, and people are willing to pay money for that. So I chose the house automation domain, also because it's a domain that everyone can relate to and everyone understands that domain. You can always think about house application domains, even if you're not a computer scientist. Some people are starting to automate their homes. And then the other application that I developed is called Autohouse. Is available on GitHub, and it's basically composed by a central server that in this case, for example, here's my computer is running in an Autohouse server, and devices that are in the application, they're called units. They are spread across rooms, and the user, I'll show it in the demo. The user can send tasks to units on rooms. They can add new rooms, add new devices, and then remove tasks running from other units. And the type of tasks that we are running are just simple house automation tasks. They're not super complicated. They don't. They do things like control the curtains, or control the AC and heating unit, or open the garage door. But if there's someone there, don't hit the person or something like that. And the device that I use to develop Autohouse with were Arduino Uno devices. They're right here, but there'll be a slide with them. And yeah, then I started developing the application. On early stages, I used a simulator from my internship, and it was really good because you can start many simulators, as many as you want, and test with various devices. And they also were used to simulate peripheral values, even though I didn't have the peripheral at the time. So if I wanted to test temperature sensor, I could just simulate it first and see how a task would work with that. And then I changed, or I took care of wireless communication, because ideally in Autohouse the device would communicate wirelessly. And even though the environment is not that big like a greenhouse, but ideally it will be wirelessly. mTask supports simulators, devices connecting over TCP, and serial communication. My first approach was to try to communicate with the devices via Wi-Fi using the ESP8266 microcontroller just as a Wi-Fi module. But I had some problems with that, because that kind of communication is made with commands, and you need to parse the commands, and I tried to use the open source libraries that are out there. They either didn't have the features that I wanted to, or they just didn't work as I expected them to. So I switched quickly to the HC05 Bluetooth module, which is really interesting because it runs over serial directly. So I can just connect the serial pins from the Bluetooth device directly on the Arduino, and there's no code change needed. It would just be the same kind of communication from the server side as it was a cable connected there. And then once I got the communication working, I started with the device deployment, and this is basically what I have here, if anyone can see. 5 Arduino boards. They're right there, they're orange ones. And then we have really quickly ultrasonic sensor. This is a movement sensor. Analog light sensor. This is a servo motor. These black ones are the Bluetooth devices. The white boxes are temperature and humidity. They all have 2 buttons and 2 LEDs. You cannot see the LEDs from the picture, but they're right there. And only one device has a servo motor, which was intentionally so we could test migration. I'm going to talk about it in a minute. So during development, some challenges showed up, and I could solve them. The first one was variables. The language, mTask language, is imperative, so it would be really nice if we had mutable data storage units. The first version of mTask did have it, the code, C++ version, but the interpreted version didn't. So I added variables back, and previously shared data sources were being used as variables. Just send a shared data source to the device and then use them as that. But there are 2 problems with that. First, shared data sources should be different things than variables. Shared data sources should be shared among different tasks, devices, users, or even systems. And a variable should be something local that local to a method or a task or something local. And the second is that on the interpreted version of mTask, shared data sources are never deleted from the device. When you send a task that uses a shared data source, the task is sent with the shared data source, but the task doesn't know that the shared data source is there, or the shared data source doesn't know the task is there. So when you remove the task, it's just the shared data source stays there, and it's even possible to have a device run out of memory because there are too many ghost shared data sources there. So variables, they're sent with a task and removed with a task, so they never stay there forever. I added new peripherals. Basically, the interpreted version of mTask didn't support any of those peripherals directly. And yeah, that requires some time. And then the requirements view was a new view that I added to the language, because previously you could send any mTask task to a device, even though that device didn't have the capabilities to run it, for example. I'm talking peripheral-wise. I'm not talking about the size of memory or something like that. If your device didn't have a servo motor and you send a task that uses a servo motor, the device would just ignore it, and there was no way in mTask to know, will this task actually be compatible with that device? I created a requirements view that would, if you give it an mTask to it, it would just return you the minimum device requirements necessary to run that task. So I can do 2 things. If I select a device and I have a list of tasks that I have available, I can filter the list of tasks based on the requirements of the device. and the requirements of that task, or the other way. If I have a task in a list of devices, I can filter the list of devices based on the requirements of that task. Also, mTask didn't recognize devices connection. For out of the 3 types, the simulator would just never get connected, and the TCP would actually throw an iTasks error, and that was good. But the serial communication would just kill the application without saying anything if a device was disconnected. So not only I had to fix that and make this so the simulators will also get manually disconnected intentionally, but also the function that you call to connect to a device would get a device error handler as input in case the application using mTask wants to do something with that device handler, saying, hey, if the device disconnects, you can do this. And that's what we're using. And I did some simulator improvements based on the feedback that I got from my internship presentation, and namely I put breakpoints in the simulator, so you can set breakpoints and then step over them, then remove them. That was really helpful during development. And also I can simulate peripheral values, which previously was not possible, which was really good during early stage of development. And there were some limitations of the mTask that I either didn't know how to solve, or don't know how to solve, or didn't have time to. As I said before, SDS live forever and they're never removed from devices. In my opinion, you should send the device or the SDSs along with a task in a bundle, and when you remove the task, you remove the SDS as well if you want to use it. There's an unwanted SDS loop. When the server sends, or when the client says, hey, I'm publishing a new value for this SDS, their server says, oh, good, I got a new SDS publish value, and I'm going to let everyone that is using SDS know about that. And it's going to tell them one by one here, this SDS value change, but it's also going to send a message back to the device that triggered that update. And that is not only unnecessary communication with the device, but it can leave, or it could cause unwanted behavior. Because you can have a race condition between, what if the device between that, it already updated another value, and then you just keep doing that, and it's just, there was one example that I could run that actually, that happened. There's no task acknowledgement communication. What I mean by that is when iTasks send a task to a device, there's an acknowledgement that the device sends back saying, hey, I actually got this task, I could run, or I could read all of it and put it into memory. But then the application that is using mTask doesn't know about the acknowledgement. And that was useful during our development at Autohouse, for example. If I'm sending a task to a device, I want to know if it actually got there so I can perform some things with it. And finally, there's no floating point arithmetic on the client of the interpreted version. And especially for some sensors, it's extremely useful to have, and they actually work with floating point devices. They will give you data based on that. And I try to mimic floating point device using integers, but then you lose precision, and the range of numbers that you can represent is not good. And it's just better if we actually support floating point arithmetic. Task migration. Ideally in Autotask, if a device disconnects and another one has the same capabilities of it, the task running the device that just got disconnected should migrate automatically to another device that has the same capabilities. And that was a robustness requirement, so we can have an application that can deal with devices being disconnected. And that's why I needed the connection error handler in mTask, actually. So I can only migrate devices that get disconnected if I actually do recognize that they're getting disconnected. And this was accomplished outside of mTask. Besides the connection handler, everything else in migration is done by the application. So the application is responsible for the rules of migration and all of that. In Autohouse, I only have one type that defines those rules. It's the migration strategies. The first one is do not migrate. It's basically don't migrate the task at all. I don't ever want you to migrate it. Migrate a task to devices in the same room, or to devices in any room. And it also uses the requirements view that I talked about earlier, and then only will migrate tasks to devices that are compatible with it. And here's just the demo now. Okay. this is, I'm not sure if it's going to work after the reboot because Macs are not good. And this is how you can manage your house. There's a living room there already. You can manage units, so have a list of units here, and you can send a new task. This is a list of tasks that we have. So you want to create a device, you can just come here. And I have a button that would connect all Bluetooth devices, but I don't know if after the rebooting the computer will work. They're actually connecting, good. It takes a while. So, and I think as they're connecting, they will show up here. The last one now. Yes. So this was just a message. They're not really friendly, but anyway. So you have all the devices here. They're connected. And as an example of the task migration, I'm just going to send a task that is super simple, but is the only one that you guys can see here or working really well, because I cannot easily fake temperature and humidity values on all of those things. So I'm going to send the most exciting task ever. I here choose the interval that I talked about, how often you want to remember, and go to the same room. And a device is there, linking with that. So I would just keep disconnecting the devices, and then the mTask would recognize that the device was disconnected and it would just migrate to the next one, to the next one. The order is just the order which they're saved into the system, and it depends on the order they were connected. So if you just keep disconnecting, they will just keep migrating to another one. So the tasks are being migrated. The task is really simple as a blink, but I'm not showing off how fancy our tasks can be. I'm just showing off that the task migration works. It works for other tasks as well.
The task uses shared data sources. Is it also then migrated to another?
Yeah, you got the point here. And there's.
So one question. So if you were to calculate factorial on one device and per browser,
yes,
then it would continue calculation on the other.
It will restart the calculation on the other.
Oh, it will restart.
Yeah, okay. Because you cannot. The device was lost. So how am I supposed to save the state of the memory of the device if it was lost?
No, of course. But you have to share data.
Yeah. The arguments of the tasks are saved as well. So when you say, I wanted the target temperature to be 26 on the thermostat, when you migrate the task, it would also be 26. And if you change it after you sent it, then it would not send that. But it's the initial argument of whatever you send with the task.
And it's connected with the share on the server or not. So you could have information in the server and that would then be valid over all the devices.
Yeah, but technically you can, yeah. And I have I'll just send the video of the other one because it's connected devices. So, and here's just an example video of is a servo motor that is running like opening curtains, and there's a light sensor that is here, and this is a light source, which is just my bike light. It looks like it's connected to the system, but it's not. And it just happens to be a cable there. And yeah, this is an example of it working, but if I were to disconnect that device there, the first one who's running the server, it will not migrate to any other devices because there's only one Arduino board that has a servo. And we would see that no other compatible board has the same capabilities. So
what happens then?
You just get an error. Just get an error saying this task cannot be migrated to any other device. The application doesn't stop it, it will just get an error. So the conclusion, a real-life application was developed using mTask. Of course, it's not a commercial-ready application. All of that is just a proof or of an idea. And, well, it was developed. It's available on GitHub if you just want to play with it. mTask was improved during the development. I do believe that the changes that I made did make the interpreted version of mTask better. And we do know what kind of future work we want to do with it. First, the changes that could not be fixed either due to time limitations or I don't know how to fix them. They we should just look deeper into them, because some are easier to fix and could be easily done. Second, research has been done by Mart and Peter on mTask 2, which is a more task-centered version of mTask, and is also the language is functional. So they're doing research on that, and it's more TOP in general than this version of mTask that I've worked with. Due to time constraints, I could not work with it because they started working with it after it started. So I did not test for performance, either how many tests we can run on the same device. The maximum that I tested was around 3 tests. Or for how many hours can it run. There's like an error on the client that is going to stop that. I didn't test for that. I didn't test for power consumption, which is something that is really important for IoT applications. Didn't test for that. And I also wanted to test it on, yeah, he's gonna work on that. I also wanted to test if I can run an Autohouse or an mTask server on a Raspberry Pi. Technically it can be done. These are people have done it with the distributed iTasks. But for an IoT perspective, it's really nice if you can have a server on a tiny box running, because the power consumption of the Raspberry is really low, and it's also a really small device. And future work in Autohouse. Even though Autohouse was not the object or the object under research itself, it was just a tool that we use to check if we could develop our applications. I wanted to test with a bit more, trying to stretch the boundaries of mTask and see where it can get. For example, task migration works, but if you have a device with a server mode and another one with a server mode, and this one controls a window and this one controls a door, those don't mean the same thing, so you should not migrate them. So it would be really nice if the user could put tags on the peripherals, and then you could control migration based on that as well. And peripheral sharing would be really nice, which means you could run a task on a device based on the value of a peripheral that is on another peripheral. For example, you can have a task here to regulate these blinds based on the amount of brightness outside, or like the temperature of another device or something like that. That would be really nice to test as well. Any task can do that. It's just a share, so you can send. But it would be really nice if we tested with Autohouse. And this is questions. Yes.
Yes. So first of all, nice work.
Thanks.
So my question is, what do you have to do if you want to write a new task? What do you have to restart, recompile?
Oh yeah. If you want to write a new task with peripherals that already exist,
yes.
Yeah, the server needs to recompile, but not the clients.
Mm-hmm.
But not the clients, yeah. Okay. If you want to add a new peripheral with a new instruction,
mm-hmm.
then you need to do that. Mm-hmm. Because then the devices will not be able to interpret an instruction that it doesn't know. It'll just ignore, actually. That would do. I'm not sure if it ignores if it stops.
And would it be possible to create an application in which you can design these tasks and send them right away?
You could design them and send them?
Like
yes.
Without recompiling the server?
Yes, you have an editor for algebraic data types and iTasks.
Mm-hmm.
You make an editor for mTasks.
I don't know. Probably if you have yeah, because you can do things like it's static or dynamic linker and all of that. I don't know. I haven't tested. I don't know what are the capabilities of cleaning that in that thing.
Should be possible.
Yeah, well, it is a class-based embedding, so it's composed of functions.
Yeah, but that would be way more really interesting because you
maybe extra data type and maybe see instruction set and then you program. Maybe the association with the occupied data type is simply. Yeah, unless your abstract data type is somewhere in parallel with the value of the first task and then compute the second task, then of course there can be any arbitrary input. So how do you write an editor for that?
Yeah, well, you can see mTask as a macro processor. or clean is the macro processor for mTask. So in most cases, you can do this.
What I was missing is comparison with other ways to program, let's say, a house. So do you have any idea? Was it more easier, nicer, more difficult, or?
Yeah. You're talking about comparison from Autohouse and mTask, and not mTask. Is that what you mean?
No, well, there are zillions of Autohouse apps you can.
Yeah, okay, yeah.
So they also programmed in some way.
Yeah.
So how was the programming look like? I didn't saw any code about such programs. Did you like it or did you not like it?
Yeah. Well, once everything was set up and all the research was done, it was pretty easy to add new tasks, but of course I had to recompile them every time. But compared to other applications, for example, they're out there. I only check for open source applications to check for them. And for example, none of them was, from a point of a user, none of them was dynamic. You always had to upload a client on your device, and that client, for example, there are some applications that use the free matter protocol, so it would only send you could only control them sending, hey, set this value on this pin or something like that, or get sensor values. But once the server was down, it would stop working because all the evaluation was actually done by the server.
Okay.
So that was one of the applications. I don't remember the name right now. But the other applications, there are really good applications that do allow that dynamicity of mTask, but they don't support microcontrollers. They support Intel, like actual bigger computers or architectures, because behind that they run interpreters in Python or JavaScript or something like that. So they don't target microcontrollers. But I think I tested 4 or 5 open source applications for house automation, and none of them you can send task dynamically like this. And you have the evaluation of the task actually running on the microcontrollers. Okay? Because right now, if you have some tasks that are just running here and you shut the server, the microcontrollers will keep running that. The communication would not be present anymore, but they keep executing the task because all the task evaluation is running there.
They also see that the device comes live again. You just show that you can plug it out, but if you plug it in, it's start working again with the server.
No. So far, no.
But the migration only works with the server.
With the what? With the server?
Migration only works with the server.
Yeah, definitely. Yeah.
There's
Because
no
one
network and
no. One device doesn't know about the existence of the other one. They're not connected. They're all connected to the server.
Would it be possible that they send a signal that I'm live again?
Yeah.
Yeah.
Well, not sure about Bluetooth. Not sure about with Bluetooth. You can send that signal if the connection was not established. Because if that one is a slave, not sure you can connect to the computer without its acknowledgement.
Oh, that's kind of.
Yeah, with Wi-Fi, yes, because it's just a package that you can send.
Wi-Fi.
And you're just waiting for package or reading there.
Due to the Bluetooth.
Yeah.
Okay.
Yeah.
Yeah. So about home automation, the way I think about it is like you make rules. Like if I come home with a car, then the garage door opens.
Yeah.
Or if it's day, then the blinds open.
Yeah.
Stuff like
Yeah.
that. So in which situation would this automatic migration to a different device be useful? Because I mean, I have one dedicated device for my garage door. So when would I ever want to migrate it to some other device?
Yeah, that would be, I thought about this actually this morning. It would be really specific, and in home automation, it would not be that useful. But for mTask in general, we wanted to test that because if you have things for other applications, then it will become more useful. Mm-hmm. But for home automation, you're totally right. You don't have a lot of redundancy of, let's say, of devices.
Yeah, and even then, because I mean, usually you want to address a specific device, not just a device that has these capabilities.
Yeah. Yeah.
Okay.
If you go back to your slide 3 or something like you have your research question.
Yes. No. The research question was 5. Yeah.
No, this is
6.
Research question. So, actually there are 3 questions here. It's possible to develop a device application. I think the answer seems to be yes.
Yes.
If so, can the development process be improved?
Yes.
What's your answer to that?
Yes, and those are the improvements that I listed here. These are some of the improvements that we can do to mTask.
These are improvements of the language, not necessarily development process.
Yes. Yeah. Okay. Yeah. Well, when you cannot handle, for example, floating point arithmetic, I think your development process will become way harder when you cannot handle that. When you don't have task acknowledgement, for example, I send tasks to devices and I need to save which tasks are on devices, but I don't know which task was actually acknowledged by the device. If the task was not acknowledged, I will actually save that task, and if the device goes off, it would actually migrate that task that was never acknowledged to another device. So that was during development. What can I do about this? At that time, nothing, because there was a limitation. Yeah.
Okay.
But I do agree that the question should be reformulated. Like, how can I? It's both the development and the language itself.
You also said that some of them you could do time limitations.
Some of the problems, yeah.
Yeah, and others were you didn't know how to solve them.
Yes.
Different categories.
Yeah.
Can you tell me which category?
Yeah. So, perfect. Low barrier. The unwanted SDS loop or an update loop is the only one that I don't know how to solve.
Okay.
Because what we are actually doing behind is we are watching the share. The application is also watching the share, but the watch is basically it's a get that you run all the time, right?
All right.
So you will get a notification, or you would get that value even though we are not meant to. Maybe we're not meant to get the notification. Let's say, ideally, for example, if the watch function would only wait for notifications, then we could use the notification system and the parametric lenses to say, hey, don't send to that device. But it's not. It's actually just a forever get that keeps getting the value and comparing with the last one. So yeah. So that's the one that I don't know how to solve.
It's a bit strange because I understand the problem, but I don't understand what's causing the problem. Because I would expect that this also goes for ordinary shares, because there you have the same problem, that some of the tasks change the value of a share. Clearly, you don't have to tell the task that the share has changed. So I don't understand why the problem exists at all.
This problem is very old. I encountered it in the beginning, but it's because you are depending on the event system, and the semantics of a task in iTasks say that you must be able to execute as many times as you want, and then it shouldn't change. So the current system is we do a watch, and then if a share changed, then we get a refresh, and then we can read the share. So if we can somehow it's a very finicky problem. Basically, we were depending on the event mechanism, and the event mechanism is very good and very sound only if all the tasks can be evaluated as many times as possible. So a task is not only re-evaluated when some specific event happens for that specific task, but it may be evaluated more.
Yes.
And that was the problem. So we cannot depend on the event mechanism to filter
that out.
So maybe if you encode the sender or the writer in the value, you can maybe do something.
Yeah, that sounds like a very logical.
Yeah, well, I did implement it and it didn't work. But
It doesn't say anything.
no, of course. So we could dive into it.
Okay. Any good questions? Yeah, good question. All right. Okay.
Thank you.
Well, then thank you very much.
That's it.